Okay, now what we're going to talk about are the rules for making a graph. You guys have been making graphs since probably upper elementary school, but there are some very specific guidelines for making a graph in a science class and specifically physics. So it's very important that you pay attention to these because these rules will impact your grade if you do not follow them and make graphs that are bad. Okay, making a graph is probably the most important tool in physics. We say that there's a lot of math in physics, and that's true. You should know how to work with equations. I think most people would tell you that learning how to graph and read a graph and analyze a graph is just as, if not much more important than being able to do all that math. Okay, graphs help us to understand the world around us. It's an easy way to display data. Okay, so you need to know how to read a graph. As we're going through these notes, we're going to be talking about the 7 things that are needed for any graph while we're filling them in on this graph. So I'm going to be flipping back and forth between this side of the page and the back of the page, okay? Oh, not that one. The back of this page. Let me just get this one out of here, okay? When asked to make a graph, the following 7 features should always be present. I'm going to try really hard not to lose focus on this one, so if the camera goes out of focus, I'll try and refocus it as soon as possible. So, to get down to business, anytime you make a graph, there's going to be 7 features that need to be on there. If they're not on there, then you will lose points. The very first one is obvious, and a lot of these are very obvious for you guys. The very first one is title. Okay, every graph should have a title. The title should, at minimum, and this is what I would recommend actually, say the y variable versus the x variable. You don't need these parentheses. That's just my way of separating. Okay, whatever the y variable is versus whatever the x variable is. So if we look at the graph that we're going to be making as an example here, it says an experiment is performed in order to measure the temperature of a container of liquid that is placed on a heater. The temperature of the liquid is measured when the heater is turned on and for 10 minutes after that. Here's your data table. You've got time in minutes, 0 through 10, temperature in degrees Celsius, going up the whole time. Create a graph in the space below for this data. Time should go on the x-axis, and both axes should start at 0. So, if we're going to be making a graph of this, remember, the title of the graph is the first thing you put on there, and it has to be the y variable versus the x variable. In this case, since time's going on the x-axis, temperature must be the y variable. So we write that this is a graph of temperature versus time. And that's the first thing that we need to put on a graph. The second thing that we need to put on a graph are axes titles. Okay, both the x and y axis need these because we need to know what we're measuring on each side. Even though the title tells us that, we also need to know not only what we're measuring on those sides, but also the units. We need to know the units that we're measuring the 2 variables in, because otherwise, one of the most important things that we're going to find, the slope, will be impossible to find, and it'll be impossible to interpret. You'll see in this class that we will be looking at the slope of graphs more than you ever have before. You know how to calculate a slope. You've never had to calculate a slope and have it mean something else. Okay, so we're really going to focus on slopes. So I need axes titles. Remember, it's always y versus x when you title it. So that means my x-axis is going to be titled time. And what units am I measuring time in? Looks like minutes. So I can abbreviate time for min. And on the y-axis, temperature is going to be measured in degrees Celsius. Excuse my bad handwriting. Degrees Celsius. Okay? There's the first 2 things that need to go on your axes. They have to be there. Okay? If either of those things isn't there, it's points off. The third thing that has to go on your graph. Well, now that you have the axes, we're getting close to plotting data, but before you can do that, you need to have your axes scales. You need to know, well, okay, what do all these different lines represent? When you're making a graph on graph paper, it should take up at least half of the page. And this is actually a scaling issue because if you scale it improperly, your graph won't take up half the page. Using appropriate numbering scales on your axes will help, and here's how to do this. Each axis should start at 0. The only exception to this is when you have negative data, which you will sometimes. Otherwise, your axes should start at 0. The biggest thing, which you've done in the past, which I can't stand, is you are not allowed to do that little squiggle thing that means, oh, this starts at 0, but my data doesn't start until like 750, so I'm just going to put a little squiggle, and then the next box up is 750. Okay, you've all seen this done before. You're not going to, in this class, put a little squiggle here and then just jump a huge range, okay? Your axis the whole time has to go up by even amounts. It can't just jump randomly, all right? The reason you can't put one of those squiggles, and it has a real name, but I can't remember what it is. The reason you can't do that is because one of the things I'm trying to teach you to do is how to make a proper graph that doesn't contain basically lies and misinformation. It's very, very easy, if you don't follow these rules, to lie with a graph and to make trends either seem bigger or smaller than they actually are in importance. We don't want to do that, okay? Watch any news source now, either side really. Both sides have different, both sides will put out, or news sources in general, regardless of who it is, will put out graphs that are very, very misleading, okay? And really that's anyone. It's your job as an informed citizen not to be fooled by graphs that try and make you think one thing when in reality the opposite or neither is true. Okay, so we have to scale it, and this is actually kind of tricky for some people. They worry so much about how to scale their graph that they end up taking like 5-10 minutes trying to figure out the perfect scale, all right? Don't do that. You should be figuring out a scale within maybe 30 seconds of looking at the graph. The way to do this is to find the best scale. What you're going to do is you are going to divide the highest data value for that axis by the number of boxes you have to work with. Divide the highest data value for that axis by the number of boxes that you have to work with. And you're going to use the nearest nice, easily countable number. 1, 2, 5, 10, 20, 50, 100, etc. Okay? You don't have to use these numbers, but it will make your life a lot easier if you do. Okay? Sometimes I've seen people try to number their graphs by like 6.25s, and it's just ugly. It just doesn't make any sense. It's much, much harder on you. Choose a nice even number. Even if it doesn't take up exactly the whole page, that's fine. Okay? So on our graph that we're making, let's do time first. All right? So we have time going from 0 to 10. So the highest data value that I have is 10. Now I have to count, really I guess it's, the number of boxes. I know that I'm going to start at 0. So I'm going to put a 0 here. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so I have 30 more lines to work with. So, because remember, you're not really numbering boxes, you're numbering these lines in between the boxes. If I have 10 minutes to spread out, and I have 30 boxes to do so, one of the easy to do things might be, okay, and this might sound like I'm breaking my rule, but what if I made every 3 boxes 1 minute? That would work out just fine, because then I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So every 3 boxes is 1 minute, and that works out just perfectly. And that's really easy for us because we only have whole numbers of minutes. So I know exactly what lines have to go on. Make sure you're numbering your lines properly and not accidentally skipping a line or double counting something, because I will be checking for that. The temperature, the highest value is 95. So again, this is going to start at 0. Let me count. I have, okay, how many more boxes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28, 29, 30. So 30 once again. I need to take 30 boxes, essentially, and somehow scale that to 95 degrees of range that I have to show. So I'm going to do 95 divided by 30, and I get 3.16. Now, does that mean each box has to be 3.16? No, you'll drive yourself absolutely crazy. What I would do instead is I would number, I would go, the nearest nice, easy to use number would either be 4 or 5, depending on your preference. If we did 4, yeah, that would work just fine. So I'm going to number each of these going up by 4s. But I'm not going to take every single number and put it on there. Instead, I don't have to number every single line, but instead I will use a pattern. So what I'm going to do instead is, instead of numbering every box with a multiple of 4, I'm going to number every 5 boxes with a multiple of 20. It works out to the same thing, because if I have 0 here, that would be 4, 8, 12, 16, 20. So this would be 40, 60, 80, 100, and 120 up here. Okay? So if I wasn't talking you guys through this, I could have done that very, very, very quickly. Okay? Making a scale is very, very important. Make sure you take your time on it, but also don't take too much time. Next comes the data points. Okay? The easiest part of graphing is actually putting the data points on. Take your time, don't mix up your data. All right? So the easiest thing to do here is just, okay, 0 minutes, temperature is 18. So let's see, I said this was 16, so this must be 18 right here. Make your data point. You don't need to put anything around it, just a little dot, okay? Color it in so it's a little bit bigger. A 1, okay, so at 1 minute, after 1 minute, temperature is 26. So I have 20, 24, that must be right here, 26. Okay, 2 and 33, so let's see, this is 32. Make sure it's really helpful if, when you make your scale, if you make your scale by 4s, it's helpful if you know how to count by 4s. So 2 and 33, 3 and 40, very easy. 4 and 45, so 4 and 45 is right here. 5 and 53, so let's see, that's 52, here's 53. 6 and 62, halfway up this box. 7 and 71, let's see, that's right here. 8 and 79, right about there. 9 and 86, right here. If you start to get confused or dizzy because you're looking at so many lines, what I sometimes do is I just take another piece of paper and I put it like this so I can tell which lines the point is on. So I know this one's on the 9 line, but I'm looking over here, it's between the 84 and the 88, and the data point's 86, so I know I'm on the right spot. And then 10, 95, that would be right up here. See? Data points are kind of easy. Now comes the analysis part. You've made your graph, but now you have to do the analysis. So the first thing that you're going to do with your analysis is draw in a best fit line. And some of you might have done this before in math classes. So, okay, looks like we're still in focus. The best fit line. The best description of a best fit line, or a line of best fit, however you want to say it, is it's kind of like the mathematical average of the data points. It is there to show the trend in a graph. Now, a best fit line is not the same as connecting all the data points. Under no circumstances should you ever, ever, ever just simply connect the dots. If some of your data points get connected because they're on the best fit line, fine. But you should never, ever, ever go individually like, okay, I'm going to connect these two, and then these two, and then these two, and these, and have to like move your ruler all over the place. All right? A best fit line is done a little bit differently. Never, ever connect those data points. You need to use a straight edge, like a ruler or a protractor. This is why I tell you to get protractors, because not only are they straight edges, they also usually have metric markings on them and angle markings. You use a straight edge. There should be no change of direction. It's a line. Lines have one direction only. The line should come as close as possible to each point. A general rule of thumb, meaning it doesn't happen every time, is that you should have half of your data points above and half below. But this does not work every time, okay? I get people telling me all the time, well, I drew a best fit line like that so I could have half my data points above and half below. That's a general rule. It doesn't always work. For instance, if you have data like this, okay? If you have data like that with one outlier but the rest of them are in this nice trend, you wouldn't do this and say, well, half are above, half are below. That doesn't illustrate the trend of the data, okay? Your best fit line would really look something more like that, with it being just a little bit above your data points because it's getting pulled up by that outlier, all right? Your best fit line should intersect some, or may intersect some data points, most likely not all of them. Okay? So if we're drawing our best fit line, okay, don't take more than 5 seconds to figure this out. Take a look at your data. Say, okay, I think my best fit line goes, oh, let's see, probably, that looks good. Done. Okay, that's as quick as it should go. You don't have to worry about how many are above, how many are below. Get it close, draw it. Okay, now be reasonably accurate, but don't spend a lot of time drawing it. Once the best, sometimes you might have to draw a best fit curve. These are trickier, but you get better at them with practice. Do your best to draw a very smooth looking curve. Once you have your best fit line drawn, you will primarily use this for any calculations. The point of the data is to get the best fit line, because the best fit line itself is more valuable and more meaningful than any individual data points, or even the collection of data points, okay? Once you draw the best fit line, you almost, with one exception that we'll talk about, once you draw the best fit line, you're done looking at the data points. Now you're looking at the actual line itself. Much, much more important, okay? There's 2 things left to do, and they're kind of related. Number 6 is the calculation of the slope. You have to, and again, remember, all these things have to go on there. You have to have a title, have to have axes titles, have to have scales. Obviously, data points. You need a best fit line. You need to show right on the graph, in a space without data points on it, your slope calculation. Slope is a measure simply of how steep a line is. Okay, that's all slope means. It's how steep the line is. If you were trying to explain it to a 5-year-old, the 5-year-old understands steepness. Slope means steepness. If you have a greater value, that represents a steeper slope. Okay? To calculate slope, you are going to use the following formula. The slope formula is the change in y, and I know this is really cramped writing, over the change in x. You might remember this as y2 minus y1 over x2 minus x1. All right? Where 1 and 2 represents points that are on the best fit line. They have to be on the best fit line. If they're not, then you're not finding the slope of that line. Okay? They do not necessarily, and probably shouldn't, be data points unless they are directly on that line. All right? Let me give you an example of how to use the slope formula. After drawing a best fit line for a graph, you use the points on the line 5, 20 and 8, 65 to find the slope. Determine the value of the slope below. Well, slope, we know, is change in y over change in x. Those triangles are deltas. That's a Greek letter that means change. You can also think of this again as y2 minus y1 over x2 minus x1. This means the change in the y coordinates minus the change in the x coordinates. Our y coordinates here are 65 and 20. y2 is 65, y1 is 20, x2 is 8, x1 is 5. Now we simply find the difference of the top and the bottom. 65 minus 20 is 45. 8 minus 5 is 3. We divide, and we find the slope of this is 15. Now this is the only slope, or one of the only slopes you'll see all year in which we didn't have units, okay? If the axes have units, and they almost always will, the slope will have units too. That will be whatever the units on the y-axis are, divided by whatever the units on the x-axis are. Okay, y units over x units. Let's find the slope here. And again, we're going to do it right on this. So, I don't like to use data points. I like to look to see right where my line crosses one of the grid, crosses right at one of the grid intersections. So I'm going to pick, let's see here. This point looks pretty good. This point right here, and this point right here. Okay? And I'm going to read what those, okay, so we have slope, change in y over change in x, y2 minus y1 over x2 minus x1. Now I just read the coordinates. The y coordinate of point number 2, this one over here, let's see here, I follow it over, 76, and that's 76 degrees Celsius. This one is 24 degrees Celsius for y1. X's might be a little tricky here because notice that it's 7 and 3 boxes and 8. So that means this is like 7 and 1/3, 7 and 2/3. So this is like 7.3333333. This is like 7.6666667. I'm just going to round it to the thousandths place. So I'm going to say that this is 7.667 minutes. And this is 1.333 minutes. We're going to find the slope. 76 minus 24. 76 minus 24 is 52. Over 7.667 minus 1.333. 6.334. You're not going to leave that. You're going to actually do the math. So 52 divided by 6.334 is 8. We're going to call it 8.21. That's okay. So we're rounding to the hundredth spot, and let's see. That would be the y units over the x units. So that's degrees Celsius over minutes. Degrees Celsius per minute. That's the slope. You have the calculation right on there. All right. I know this video is running long. I'm going to fit one more thing in. The very last thing you need on a graph, or otherwise you will lose points, is the equation of the best fit line. You need to have this. The general equation for any line is given by this formula. Y equals mx plus b. You've seen that before. The variables in here, the things that can change, are x and y. M represents the slope, and b is the y-intercept. And if you remember what the y-intercept is, it is where the best fit line crosses the y-axis. So on our graph, we take a look. We go to write our equation for the best fit line. I fill in my y equals an x. We'll talk about what those actually mean later on. The slope goes next to the x, getting multiplied it. The slope here is 8.21 degrees Celsius per minute. You do need the units there, so 8.21 degrees Celsius per minute. And the y-intercept, this looks like it hits the y-axis right about at 18. So I'm going to write plus 18, and the units on the y-axis are degrees Celsius. Okay, so I've got everything that I need on my graph. Title, axes titles, axes scales, data points, best fit line, slope calculation, and the equation of my best fit line. We'll talk about what the slope and the equation of our best fit line mean and how we analyze them in the next video.